So the sun is approximately 93 million miles away from the Earth, which is a pretty great distance that is. Now the sun is made up of mostly two things. It's made up of hydrogen and also helium, one of the two most important gases in our entire universe. So the sun has all these gases, right? Well, what happens if the Earth were to be struck by a giant meteor or a supernova went off? Obviously, it would make a giant explosion and it would probably kill everyone in the world. It would be bigger than the meteor that killed the dinosaurs, which is just incredibly huge. It would be bigger than if you sent off 100 nukes. Now, this has some consequences, because obviously humans would not exist at all, and everybody would just be dead. Let's face it. So, what we would know, though, is roughly in 3.5 million years, we could see this meteor in advance, so we could prepare for it. Now, scientists have theorized a couple ideas on how we could prepare for it, but one of the biggest ideas are stellar engines. So these stellar engines have two main types, type A and type B. So type A is like this giant mirror that's theorized that bounces light off of the mirror and propels us, and type B is a giant rocket. So what is a stellar engine? Well, a stellar engine is a class of hypothetical structures which use stars in our galaxy to create usable energy. So in our case, the sun, which is our star, some variants have this energy to produce thrust and thus accelerate a star, moving the whole star and anything orbiting around it in any given direction. While that may seem simple, we have to know first what a stellar engine looks like. And a great reference is the Kaplan thruster by Professor Kaplan of Illinois. And he theorized more of a rocket booster type thruster, which uses the sun's energy to propel it. Now, this is just massive and would use so many resources on Earth that it's impractical that we could even use the Earth for resources. Plus, there's a disosphere, which is on the outside. So we would actually have to farm 40% of our planets because the disosphere uses mirrors and other technology to focus the sun's rays, beams, and particles back into the machine. So once these particles go in, you're getting a mixture of helium and hydrogen particles that go inside. And these are basically what the sun is already made up of. And the sun is so huge that it won't do much. So the first step is it has to push out some sort of thrust. So it actually pushes out oxygen, which it is made from the fusion reactor. And it also has a particle accelerator. Now this particle accelerator shoots back hydrogen at the sun, and this is because if we didn't have that, it would just go into the sun and just disappear. But that hydrogen jet pushes the sun away, right? So this moves the sun, which also moves the Earth while staying in rotation. Our system would move 50 plus light years in just roughly a million years, which is incredible. That means we could dodge a supernova or anything big like a black hole that could suck in the Earth. And that's without sending everyone on a rocket mission, which would be impossible. So this has great benefits, and it uses magnetic fields to put in the particles, so it doesn't have to use anything external. So this is just one of the types, and there are plenty out there. But it can't be built right now, and it would take millions of years to make them.